Hi, Nikolai. Welcome back.
Hey, Adam. Thanks for having me.
The last time you mentioned that what you are doing, you are listening the entire day, or you are scraping the entire day the mailing lists from the Java news, and the point is you would like to get the news as soon as possible. So for me, it sounds more like the how it's called the broker systems where you are very interested in the current stock prices. So you are very close to the source, right?
Yeah, kind of. Although I have to admit, I would like to spend all day on the mailing list, but actually I can't. So I occasionally also get like good tips elsewhere where people read something interesting on the mailing list.
Okay.
But yeah, I think there's so much good information on there. But like following all of them is basically impossible. It would be a full day job, I think.
I thought this is exactly your job, that you are like the how is this catalyst between the mailing list and community.
Yeah, I mean, like, well, kind of, but also recording videos and giving talks and editing and writing and all of that. It takes time too. So there's actually not that much time to be on the mailing list. So what I do is a lot is actually. So the mailing list is. Okay, let me start elsewhere. The question is, what kind of information do you want to pick up and who do you want to present it to, right? So there's all kinds of Java users out there, right? So we could basically start with somebody who's like coded Java for a couple of years and has really no interest in whatever new happens because for them it's just a job, which is a fair way to see it as well. They just use whatever Java version they have in front of them. If they see a new feature, they maybe go read up on it. But then there's also developers who are always interested in what comes out in the current version, right? So whenever a new version drops, they realize, okay, 18 is around the corner. Let me read up on what's in 18. And then there are people who are interested, and that's even further on the edge, right? Of the cutting edge is what JEPs are there currently, right? Mm-hmm. What JEPs and JEP drafts, which are already a little bit more experimental. What are those? And like, of course, like the further we get, the fewer people are actually interested in that. And then at the end point of that, like at the pinnacle is what happens on the mailing list, right? So the mailing list is probably it's the earliest way to see new information, but it's also at a point where a lot can still change, where things are still being discussed, and where there's a lot of more time investment required to really make sense of it all, right? So I think for most Java developers interested in the newest stuff, I think the JEPs are the sweet spot. While JEPs can change, and even a feature that was, as a preview feature can still evolve in the future, I mean, it does happen, they're still somewhat stable, right? It's not like you're not going to read a JEP, or let's say you're not going to read 10 JEPs, and then by the end of it, only 2 of them make it, right? So usually there's like a good chance that a lot of the time you invest into reading a JEP and understanding it and maybe experimenting with like an early access build, most of that time is well invested because most of that will be stable.
Yeah.
And so I think that's why it's a sweet spot. And that's actually where I spent most of the time. We also look at, what to present, what to discuss on Twitter, or maybe what makes it into the newscast, because that's the stuff that's around the corner. But we already have a pretty good idea of what it will actually look like. Mm-hmm. And then the mailing list goes beyond that. It requires much more time investment. And then also like the payoff is lower in the sense that, you cannot rely on like somebody, throws out an idea on the mailing list and you can't rely on, okay, that's probably going to make it. That might just, get kicked out of the idea room or of the idea list a couple of weeks later, maybe, because it's always a balancing act, right? With any software development project, there are tons of good ideas what to do, but you always have to pick the ones that you feel make the most sense and have the best characteristics of investment versus the benefit to the users in the end. So lots of ideas that get thrown around are not pursued because they're bad. A lot of them are just not pursued because they seem to have a worse payoff, basically, right? From investment of resources to benefit to the user than some other ideas might have. Mm-hmm. It actually happens frequently that people are like, why don't you do this? Is this a good idea? And the reply is, yeah, it is. But, what else should we then not do? And that because that's always the question, right?
So why developers should be interested in, JEPs or the new stuff? Or why they are interested, you think? What's your observation?
Yeah, because I was going to say, like, I don't think, like, they should in the sense there's no moral obligation, right? So I really understand people perfectly well who say, look, like, I do this for a living. This is my job and I enjoy my job, but I don't enjoy it to the level of investing all my free time. I think that's a perfectly good and reasonable point of view to have. So I don't think people should be spending 8 hours at work and then 2 hours at home, reading up on all kinds of stuff, but they can. And I like to do it. And I think a lot of developers like to do it. And if they do want to do that, right, if they do want to learn more about Java beyond what they technically have to know for their job, well, there's no video, but I just had air quotes here. Yeah. So beyond of what you have to know for your job, if you're interested in that, then yeah, I think that makes a lot of sense because like when there's a new feature in Java, there are different things to learn. There are things to learn like just how to use it, right? That's the most basic thing you want to learn first. But there's more. There's how am I supposed to use it, right? It's not only how it works, but what are good applications? What might be bad applications? Where's the sweet spot? And that's of course something that we also just tend to figure out while we go. So that's always interesting then to read what other people's what other people have opinions on these features and how to use them. I don't like the term best practices, but I like the idea behind them. So let's say I like to call them good defaults. So what are good default use cases for this feature, or what's a good way to use it? And then beyond that, and that's something that interests me personally a whole lot, is the why question. So why is it there now? Why wasn't it there before? What changed? And there's often a lot to learn about Java's history. So for example, just like a really small detail, in Java 9, since Java 9, when you use a try with resources block, right? You say try and then in
Wait a second. We'll come back later. I give you an idea because I ask the question on purpose because I'm really interested in the newer stuff. Maybe not cutting edge, but if there is no 50-50 chance that it will make it, I'm interested in it. And I was always interested in it. Also, was one of the reasons why I also attended Java 1 back then. Because I was interested in what's coming, in Java EE, microprofile space in Java. Why this? Because for me, Java is something like a standard, right? Because whatever ships with Java, it is already there. I don't have to justify it. I don't have to patch it. I don't have to care about the dependencies. I don't have to check, the licenses model or whatever. So for me, it is the simplest possible and most productive thing if it already comes with Java. So it is actually really important to know what's on the horizon. Because I spend, my time as a consultant in projects, so sometimes about architecture, kickoff, or whatever. And the question is now, should we use this external dependency now? But if you already know that Java comes with something similar, you can say, wait a second, maybe, we should, stuck with Java now. And if it makes it, we can save a lot of trouble later. Yeah. So for me, it is very important to know in which direction Java is going, so that we don't rely too much on external frameworks, which are too similar to future Java. And what I remember is before Java 8 came out, so there were no streams, obviously. And I was in a meeting, and a company tried to sell us a framework which was very similar to Java streams, like high performance stream computing or whatever. And I say, okay, wait a minute. When Java 8 came out, and it was already on the horizon, I remember I was back from Java 1, and you could already try that, but there was no GA. And I said, okay, this will completely kill whatever we did. So if we would use, this proprietary feature back then the entire project wouldn't be successful. So after 2 years, it would completely die. We would get, overcomplicated solution, which would be unpatched because there would be no survival chances for Java, for this framework, for the external framework. And we knew that. So what we did, we presented to management and said, look, Java 8 is preview. The project will run for several years. Maybe we could use Java 8 preview right now. It is risky, but it's less risky than using, the external proprietary framework. And so for me, knowing about the future is about risk management. So you know what's coming, and very similar. And I mean, it happens, Java records, the next thing, Java 11 HTTP client. If you know about Java 11 HTTP client, the question is, do you really need, an external HTTP library? So the discussion we had briefly on Twitter, the internal syslog in Java. So I used that already because for me, this was also funny on Twitter. I missed the entire log4j problem. It was like 8 hours later, and for accidentally we had a conversation about external dependencies, and log4j was one of them. And for me, I never used log4j because for me Java util logging was good enough, and sometimes these what's called the internal syslog Java, I forgot the name.
The new one, System.logger.
The old one, JDK 9, I think it was, right? The System.logger, right?
Yeah, you're right.
The newer one, the Java System.logger. Exactly. So and I use the System.logger, and I use the Java util logging, and what I also use for serverless, I use system out println, works perfectly fine, wrapped in with a interface, and there is no concurrency, so no one cares whether there is synchronized or not. And it was unfortunate because people suspected I'm bashing on Log4j because of the bug, which I just didn't recognize back then. So for me, it's about knowing about the future. It's knowing about what standards may come, and then we don't have to care about external dependencies. So this is one of my motivations.
Yeah. So I think what I fell into the idea of like replying to a question basically like what like the like average regular developer does, right? And there I think it's as I said, I think it's optional. But you're right. Like if you're a team lead or not, maybe it's not even the team lead's personal responsibility, but someone in a team should know, right? So specifically when you start using a new Java version, somebody on a team or in a company, there should be a way that someone is, goes through all of that. And when you start using a new version, for example, can teach you how to use these different, like internally within the team, within the company, how to use these features. And as you said, if you're involved into making decisions about where your project is going strategically, then yes, like you or somebody in that decision process needs to know. So I think, you're right. So basically what I just said was basically from the from just like everyday coding developer. Not everybody has to know. Once again, I think like many of us are also in this industry because they came here like driven by curiosity, right? I think probably the older we are, the more we're in here because of curiosity, right? Because it was not like when I started going to university, it was really just like already a normal trajectory to just go to university, study computer science, and then become a developer. But I think like if you're older than me, so I'm like in the end of the 30s, it's most likely that you're here because you were just so interested, so curious about this, that you got in this industry out of that drive more than just picking it as any kind of just a regular job. And of course, but I still think many people are here because they're very curious, because they were interested in, tinkering with maybe HTML, with, like BASIC or whatever when they were younger. And if that drive still persists, then of course, now that you're a Java developer, you're probably also curious about, the new stuff that's happening here. And so, and for all of those people, and for all of those who, are involved in strategic decisions, there's a bunch of information out there to learn about what's upcoming in Java. But what I also try to do is...
But you say we are older. So Java developers never get older. This is, the first observation. We just, stay young forever. And what's also about future is... I think the last time we found out that you are actually a 100% Oracle guy, but I know the older Java developers come from the Sun times. And
let's just say I work there. There's still some Nikolai in me, but let's say I work there 100%. Yes.
Yeah, I mean this is the fraction of a percent of Nikolai doesn't matter if you work for Oracle. This is you only have to wait for the Elon Musk Neuralink technology, and then you are 101% Oracle.
I would like to disagree, but I can contractually. I cannot disagree with that.
Very good. No, about Sun. The Sun community back then, it was like, Sun was the driving open source force, and everyone liked Sun, and whatever Sun did was, we just accepted that and used that. And so the older of us are actually lazy. And if what I work a lot still is with Java, Jakarta, and microprofile developers. And what they really like, the idea is, we just focus on the foundation. And we really don't like, to look around, to replace some already existing Java or Jakarta E technology with something external, because it doesn't matter. So I would say we are curious, but we have to be we are more efficient about the curiosity. What I remember at the beginning of Java, everyone wanted to evaluate logging frameworks, configuration frameworks, and caching. So this was like the three frameworks. In every project, you started to implement your own framework, right? Then a little bit later, dependency injection. So even there was a workshop in Frankfurt. During the workshop, developers implemented an open source dependency injection framework. But right now, I would say I don't care at all about dependency injection or logging or caching or whatever, because everything is there. So the curiosity is about what we can actually, can we develop faster? and implement more stuff. And this is the interesting stuff what happens, right? So I would say what happens, it shifts for more boring technologies to more exciting technology. And my observation is that Java covers more and more of the boring stuff, which is really good. And we can focus on more of the exciting stuff.
I mean, yeah, but I think that's to a degree, that's also what Java tries to do, right? Like it tries to pick up stuff that's proven to work. So it makes sense that some of the stuff gets explored out there, and if the community like settles on like a common approach, then that approach maybe end up at Java as a language feature or as an API, depending on what it is. So for example, the way we used anonymous classes to pass around actions, specifically observers in the past, I think it was a really great decision to implement lambdas in a way that would be basically compatible with that approach.
Yeah.
So there was like with all these big projects, Project Lambda also explored various different approaches, and in the end, it settled on one that is really very close, like almost indistinguishable from what we used to do in the past already. We would create it needed observers, so just create an interface and had this one method. Also, way in the past, they had these observer interfaces, I think in AWT, which is like a dozen methods, so that didn't work quite as well.
Yeah.
But if you look at JavaFX, which was developed like when Lambda was already around the corner, you can see like every observer has just a single method. It was already planning basically ahead for, this is what we're already doing, and then Lambda will probably pick this up, and it did. And now Lambdas just map this single method function interfaces, which is somewhat uncommon for Lambda's work in many other languages, but it made sense in Java because that was the approach that we already established as being the one that works well in Java. And instead of like inventing a whole different solution that would then basically split all the solutions in two, like this is the old way to do it and this is the new way to do it. If possible, it's nice if the old and the new way are the same way, or actually at least very similar. If possible, right? Sometimes that doesn't work, but if it does, it's cool. Like with that approach, and I think so. In general, pulling solutions into the JDK is good, but there's of course a limit to that, right? I mean, we talked about System.logger earlier, and while I thought it was not intended to be used externally, I think I'm technically right, meaning there is no intention to tell people to use this.
Yeah,
it's still okay to use it, which was a bit surprising to me because I really felt like you probably shouldn't. And the reason why you shouldn't System.logger is it is written for the requirements within the JDK, and it fulfills those, and it won't move from there.
Yeah.
So if you think like, well, but there are these 10 great things that other logging frameworks have, the System.logger probably won't get those because it's really just meant as an API to be used within the JDK, so that you can plug your external logging library into it. So for those people who don't know what System.logger is, maybe we should start there. So System is the class System, and it has now another class .logger. And the idea behind
you say now
JDK
it came with Java 1.9, right?
Yeah, it came with Java 9, right?
Yeah.
Still, to me, it's
No,
always
the audience is thinking that now we added in Java 18, System.logger.
No, you're right. Yeah, sorry. So in JDK 9 that was added, and the idea is that all the JDK classes use it, and then there's indirection there. It will default to Java util logging, so by default nothing will change. But you can use your logging framework of choice, assuming it has that feature, to plug that in, and then it will pick up those messages. So the JDK log messages will not be a different stream. So it will not be like your log messages and then the JDK's log messages ending up in different places. You can all funnel them into the same place and then have them all in the same file, for example. Notice important, these are not the JVM's log messages. So stuff like garbage collection, class loading, locking, all of that stuff. That's something else. That's not, but this is about, for example, you can tell AWT to track mouse movements, and then you get an event like every time you move the mouse, that kind of stuff. That's stuff that are logging messages from within the JDK classes, and they would all go through this mechanism so that you can put them into your logging backend. But what that also means is, if you have a library or like even as a developer of an application, you could also just use that. You plug in log4j or I don't know, like logback or whatever as a backend to deal with writing this to disk or whatever, but you would only use System.logger. And I think that's okay, but be aware that then you have to be happy with the feature set that class has.
Which is perfectly fine. But because Java util logging is also limited, And but what changed? Why I think it is now more interesting than back then to JDK 1.9 times is because most of the server-side Java stuff is running in containerized environments anyway. So and what happens is usually you are not changing the log levels on the fly. What you are doing is you are logging everything, and everything becomes an event. Sometimes not even in a file. So just an event which is sent over the network, and the filtering aggregations happens somewhere else. So in most cases, in newer cloud projects, I could actually happily just use system.println and log everything out. Because, the aggregation, whatever the frameworks did, the filtering and formatting happens later. So what I only need is JSON formatting and, log events. So this is the only thing. And for that, Java util logging or the console, how it's called, System.logger is the proper name. Yeah. The JEP for that. So
the number of the JEP?
Yeah. We have to look it up.
No, but I can look it up on the fly.
Yeah. And the console logger would be just perfectly fine for that. And, the limitation is always the case. But from my perspective, I would like to start with Java built-in functionality and then extend from that. If it doesn't work, then I can still use external library. So the thing is, I wouldn't start with external library and hope then one day I will use the functionality. You know what I mean?
Yeah. Yeah, that makes sense. So first of all, it's JEP 264.
Yeah.
That's the one. And I actually contributed the integration with SLF4J. So but I think it's only in SLF4J 2. Yeah. It's really easy. Like, I didn't do a lot. It was basically a weekend project. And it made it into but SLF4J version 2 has been in alpha for quite a while, so I'm not sure what's going on there exactly. But yeah, it's in one of the recent versions. So if you have SLF4J on the class path, or module path, it would automatically integrate with that service, and it will automatically pick up the log messages that go through System.logger, and then it will put it into whatever backend you configured there. Yeah. But what you said about only picking up a dependency once you know that that you need this feature set, I mean, in general, you're definitely right. But there's also you probably have a good idea because logging is so ubiquitous. You do it in so many different apps. If you do something that you've done in the past, like I'm going to implement a new service for my microservice application, or add a new feature to my plugin driven desktop application, whatever. I mean, with logging, you probably have a pretty good idea what the requirements are going to be, right? I mean, like if you have new business logic, it often takes some time to explore and what do we actually want to do. But I think many cross-cutting concerns like logging or maybe like unit testing or mocking or whatever, like for those, you probably know pretty well what you're getting into. And so I wouldn't chide somebody for saying like, I'm starting with a logging library, because I know I'm going to use, I don't know, whatever feature log4j2 has that people could be interested in, that System.logger doesn't, because I think that's usually a part of your software that you probably understand pretty well in advance. And some things are like, well, not hard to change, but troublesome to change, right? So
that's the problem. You are assuming that you are, a developer, which working in a team, in a company, which might be true. My observation is different. So what you are right for specific projects. Go for it. But what happens sometimes is larger projects is like the company just picks 3 different companies which contribute the software, and now we have the problem because one company uses log4j, the other one uses logback, and the other one would like to use something different. And for me, sometimes I'm in such a project, and I say, okay, then go to a room and fight. And this is like you can spend hours or days in meetings just discussing this. Or my trick is to say, we don't use anything. We start with Java first. If there is nothing there, we extend from that, right? And the cool story is you will always find something in Java. Base 64 encoding, Java, this logging. So everything is already there. And if this is not there, then we expand to the server. So if we have, Payara or Quarkus or Helidon, whatever, with that, you can omit all the dependencies. And this is now become twice as important as before. First, you don't have to care about the dependencies. Now, company became more sensitive about the licensing. So, you cannot just pick, whatever license you like. And, of course, security and deprecation. So, I mean, security is one part, but deprecation is a bigger problem. A few years ago, I was asked, and the entire time, what's my opinion about hystrix from Netflix? I said, okay, you can use it, but I don't see the point. And it was deprecated. So if you would be dependent on hystrix, it was hugely invasive framework. I don't know whether you saw the source code. You had to build command patterns, so very similar to your observers. So back then to Java AWT observers, and configure the thing with a factory, which was painful. I say, okay, why I would like to, this is like horrible code. And now Netflix deprecated the entire hystrix. Recently, I performed another code review. And Dozer, Dozer, like, object copying, a hierarchy, hugely popular back then, now it's deprecated. So if you, let's say, we have Java records, which work fine, and the framework is deprecated, and in the project there are several hundred dependencies on this Dozer. Now the question is, what we are doing then? So I would say you can start with a dependency, but then you have to take the ownership of the dependency, maintain it, be responsible for patching. And this is what doesn't happen. The developers just download everything they can, and they put it to POM, and they have fun, and then they go away, and you are stuck, with outdated stuff. So I would say focusing on Java and, your extended ecosystem. My extended ecosystem is Jakarta and microprofile. This is what, 100% of backends are. In other projects, maybe something different. But even then, if I use Helidon, I don't care. Quarkus, they are very similar. I can just focus, on this, what the framework brings. But I don't have to discuss why I use, dependency injection Y and not Z. And this is actually my trick.
Yeah, so you're definitely right. So this being stuck in committee, discussing which logging framework is the best or which mocking framework is the best.
Yeah.
So that's actually one place where I feel that, competition is usually good, right? It gives you options to pick what you like best. But I think it also, specifically in Java, where IDEs, for example, right? We have 3 really great IDEs, and there's 99% of what you want to do day in, day out, they all do, and they all do it pretty well. So
which IDE are you using?
The best IDE? I use IntelliJ.
Mm-hmm.
So which IDE you're using? It's not essential. If you feel or which logging framework. So in most cases, since we are in an ecosystem which is so mature, which has different options, which usually do all a great job on the basics and just distinguish in the details, it's often these discussions feel so pointless because you can probably use any of the 3 and it will do a good job.
Yeah, sure.
Of the IDEs,
except
the logging frameworks.
IDE, except back then, Eclipse was still used a lot. And I forgot when. In order Eclipse to function properly with Maven, projects started to add Eclipse-specific Maven plugins to POM. Yeah. So I say, that's over. I would say, if you like to use Eclipse, but the build system should be IDE independent. Then I'm with you.
Yeah.
So I don't care about.
We had this as well, actually. A company here in Karlsruhe, Dizzy, where I used to work. When I started there, everybody was using Eclipse, and we used Eclipse internationalization mechanism, and we also used the Eclipse Maven plugin. And the problem is that the project was rather large, and Eclipse struggled to deal with a project 400 Maven projects as Maven projects. That did just not work. It just would freeze for hours at a time trying to recalculate something. And so we had to use the Eclipse Maven plugin to create these Eclipse config files.
Yeah.
And so there were discrepancies because the problem then is then what was that? Some kind.
Exactly what you are expressing right
test
now.
Dependencies.
Yeah, exactly. But I would be completely against that. If I would see this in code review.
Yeah, right. So that's the point, right? So at some point we realized that that's actually not a good idea, and it started because one guy was like, you know what? He started together with me actually at the company. A couple of months later. Robert Ledermüller was his name.
Okay.
Probably still is his name actually. So he's a great guy, and so he started why don't we use IntelliJ? I was like, I don't know, why don't we? Okay, I'm always happy to try new stuff. He's like, it has better Maven integration. This should actually work as proper Maven modules in IntelliJ. I was like, okay, sure, let's try. But he realized then that actually it doesn't just work because the project was married to Eclipse, and that was never a decision that was explicitly made. It just happened more or less accidentally. And that was something that was then discovered that actually not a good idea to have this kind of dependency established, at least without making a proper decision, but probably if we could, because if somebody would have discussed that, if there was a team discussion about should we marry our project to Eclipse, probably the answer would have been no. It just kind of happened.
Yep.
And so then he spent some time to undoing that.
Yep.
Spend some time to make sure that it would actually be just Maven, and then you can use it in Eclipse or in IntelliJ. And that's when I started using IntelliJ, basically just because the Maven integration was just better, and it would just do that specific job better. But I think it benefited the project immensely to be IDE independent, and that's in that specific situation, I think was a good choice. But I want to come back to this idea that
about IDE. I would like to say something about IDEs. So I use Visual Studio Code, which is basically Eclipse nicely wrapped recently. Because I can use it as an editor, and if it finds no Maven projects, I can just start hacking and then still use for my HTML and JavaScript and CSS, whatever. So I'm just using as a mix of editor and IDE. And NetBeans came out at 12.6, the new one, and I use NetBeans a lot. So I open NetBeans, so I download NetBeans, and I say it's crazy how fast it is. So it is a lot faster than Visual Studio Code, and I was already happy with Visual Studio Code. And my hope was, Visual Studio Code is good enough, and now now NetBeans is also great again. So so this is great times actually, and I also have the subscription from IntelliJ. The problem is with IntelliJ, I'm a consultant. It is a paid product, so I cannot just require all the companies just use IntelliJ because I have it. And the nice story is you can come in with NetBeans or Visual Studio Code, and they are completely free. So I can say, okay, look, you start now, and you have exactly the same environment what I have. So this is the only thing.
I think as during trainings you would have to use the community edition, right? Like you cannot be like, well, I'm going to show you stuff.
Yeah,
but
exactly.
That stuff you actually have to pay, because the community edition is pretty great in IntelliJ. But as if you're showing people what to do, I wouldn't use the features of the paid version either. So that would probably be helpful to have the community version there.
Yeah, and my project is my problem in there is on my YouTube videos. Sometimes I get comments, okay, there's too much magic what you're doing. What was it? And there's actually no magic at all. Sometimes I have a small script which copies something, and people suspect something happens behind the scenes because it looks like so easy. So for me, the less the more open source stuff I'm using, the better it is, because I'm a consultant, I have to do some strategic decisions, but always end up in code. So for me, it is important, to show, okay, if we just, do this way, it will work. And I have to interrupt you because you said something interesting, and I interrupted you 10 minutes ago about why JDK 1.9 and try with resources. This was really interested, and we should, keep this because this just. I wanted to hear something else, but now is, I think, the time to discuss about your JDK 1.9 and try it with resources.
Okay, probably, Adam, I'm going to make myself very unlike now, but no, I will do that in a minute. Quickly, I just want to finish that thought about the competition and different things like logging and mocking. So basically, the thought is, yes, competition, great, but also leads to these long discussions about what we use, and sometimes it feels really good that some of these things, like some of these thoughts have been fought and somebody won. So when I use mocking now, I use Mockito, and I'm not thinking about any of the other ones, because that's just the one that apparently won, which to me means it has like overwhelming share. I think, at least that's my impression, in new projects.
Yeah.
That's what people mostly use now.
Yes.
I think also kind of JUnit won that thing,
yeah.
Specifically JUnit 5. And that just makes it easier because you don't have, because you probably need a unit testing framework, but now you don't have to have oh no, let's use TestNG, no, let's use JUnit. Those
but
files
JUnit
are behind
5,
us. We can now just pick the good one.
Yeah, but JUnit 5 almost screwed up because what I remember, they removed the Hemcrest libraries. So in JDK 1, JUnit 4, I could just stick with one dependencies, and I need now two. And I don't know whether they remember, with JUnit 5, the Surefire plugin was required in Maven, so the setup was more complicated at the beginning. But now now it works better. But Mockito, I'm with you. But I can tell you why it won, because the competition back then, how it's called, the competition EasyMock. You had to record.
There's even a third one.
Yeah, there was a third one, but you had to know to call record and whatever. And Mockito was just clean and easy. So this is why it won.
Yeah, sure. I mean, it just turned out to be the better one. I just determined by winning. I said, I determined that seems to be what most people just use.
Yeah, exactly. You're right.
Also, assertions, by the way, I have a strong distaste for Hemcrest because I don't know it. I don't know the entire API from the top of my head, and I feel like when you don't, it's actually hard to explore. Yeah. I really like how SRJ does it, for example, just to assert that. So, but anyway, so the point I was making is,
what I need, Nikolai, what I need,
that this being stuck in committee sucks, and it's good that some of these wars are done, and now we can just pick the winner and not have these long discussions.
Yeah. Assert that. This is the only thing I would like to have, Assert that, and this is not part of JUnit 5, but was in JUnit 4. So assert that.
Because it like, so the idea behind JUnit 5 is it has basic assertions, but the team said there are great assertion libraries out there. We're just going to provide the very basics.
Yeah.
You can use them out of the box, of course, but we recommend, like, for real life projects, you want to probably pick some assertion library.
Yeah.
So instead of trying to come up with instead of providing assertions for everything, they just said, okay, we're doing the basics. You're going to probably pick something else anyway, which is already out there. But what JUnit 5 will not do, unlike JUnit 4, it will not drag in an extra dependency like Hamcrest and basically present that to you as the default, because that's what JUnit 4 did.
Yeah,
and
a subset
that
of
was a good decision.
Yeah, JUnit 4 was a subset of Hamcrest. And then what I'm just missing is one thing was like assert that, because it's more like a facade, to the others. And this is what I would like to have, just one thing, but I understand it completely. But you're right with Hamcrest that yeah. But if the problem with assert equals and assert true is I always mess up, the order. The first one is that's the problem. The first is, I think, expected, and the other one is the actual. And I don't even know whether this is correct. I have to look it up. And with assert that, this is clear, because you say assert that this is, and this is the nice thing. So what I'm just missing is assert that. This is the only thing. Okay, but
but I never use JUnit 5 assertions. I just always use SRJ. In an open source project we even make the rule, we always use SRJ, even if in that specific instance the JUnit 5 assertion would work just as well, because then we have to have discussions. But look, in this case, it works better than let's just always use SRJ.
Interesting. Interesting design decision. So you are always using SRJ.
Yeah. Okay. So because the point is, to me, if you have several developers, and then specifically also you have pull requests from outside contributors, I don't want to end up in a conversation about, well, in this specific instance, maybe the JUnit 5 assertion is better, because in maybe in 1 or 2 or 5% of cases it might be. But instead of then in 20% of the cases having that discussion, or being disgruntled because, well, I don't want to fight the contributor over this minute detail, but also I don't really like that. So no, let's just not have that discussion. SRJ is pretty good in 95% of cases, and even if 5%, writing assert that X is true is more work than writing just assert true. Let's just do it anyway, and that way we have a uniform solution. And then we don't have to discuss these specific details. We can spend time on the pull request focusing on more interesting stuff.
No, that's very interesting. Interesting decision, actually. I like that. So you say, okay, we don't use for JUnit because JUnit is incomplete. JUnit assertions, JUnit 5 assertions are incomplete anyway. So we are just using external assertions. But this would be actually also an interesting, design decision for JUnit 5 itself. So they say we don't ship any assertions.
I think I think they want to ship the basics because
but this is the problem. That's the problem.
Yeah. But they use SRJ as well, I think. As far as I know, internally, they use SRJ as well. So they use their own assertions to a point, but they also use a lot of SRJ, if I remember correctly. I would have to check the code base. But now I'm done with that. We can go back to Java 9 if you want to.
No, just about thought, because what you said back then is what you're interested in is why something happens. Yeah. And you mentioned try and resources with JDK 1.9, and I interrupted you, but I'm really interested what you wanted to say back then. So
let's do that. So if you use try with resources on Java 8, so let's say you got, an input stream. You already have the stream, right? Mm-hmm. And now you want to use a try with resources block, like the try block, and then in parentheses, you put a resource there. And what Java then promises you is that at the end of that block, it will close that resource. No matter whether it's exception or not an exception, it will definitely call close it on that thing. So in Java 8, what you have to do is, if you already have the input stream, say, that you want to use, you have to assign it to a new variable. Mm-hmm. And in Java 9, you don't. You can just say try, open parenthesis, the name of the variable, close parenthesis, and then go. So the interesting question then is, so why was that changed in Java 9? So why is that, what was the reason that we had to do the assignment before? Because it's weird. If I already have the variable, which let's say in this example, the input stream, why do I have to assign it to a new variable? That's so weird. And specifically to me, that was super annoying because I tried to give stuff good names. And the input stream, say, already has a good name. I already gave it the best name that I have for it. Now I have to assign it to a new variable. That's the same thing. So I need another name that's basically the same thing, but I cannot give it the same name. So you end up with a single letter name very often. Like then the stream just becomes S, because what else are you going to do at that point? That was super annoying, but I never really thought about it. And then Java 9, when that changed, I actually read through the JEP, and it explains why it was different in the past. And the reason is that if you have a try with resources block, you have to be sure what clause is called on. You as a developer have to be sure. And the best way to make sure that you know is by disallowing reassigning that variable. And the way to do that is to make it final. So the only reason why you reassign that variable, or why you assign it to a new variable, is because that new variable is implicitly final. If you ever tried within a try block to reassign the resource variable, it doesn't work. It's implicitly final. So the decision was made to keep the code readable. The developer needs to be sure what a resource clause is called on, and the best way to achieve that is by not allowing reassigning. And the best way to achieve that is by forcing the assignment of creation of a new variable that is then implicitly final. Okay, I never knew that. I didn't know the whole thought process was new to me. What Java 9 changed was, well, since Java 8, we have this concept of implicitly final, where something is like, it could be final, it just isn't. That's what you use for Lambda parameters. So you know what? Since developers now understand that concept, let's use that concept here. And if the variable is implicitly final, you can just write try and then in parentheses just the name of the variable. So the change in Java 9 was small. You can use implicitly final variables in a try with resources block. But most of what I learned was, so that's why it was that way before. That's interesting. Like, why was it that way? And that's what happens a whole lot when I learn about new Java features, that I learn just as much about why the API or the language feature or the JVM used to work the way it was before the change. And that also informs why the change was made and how to better use that feature. And the JEPs specifically are full of those information. It's really amazing that they often, when they change something, also explain why it was the way it was before the change, how things changed now, and what triggers now the new development that the JEP proposes. So it all has these parts, like it was like X because reasons changed, so now we do Y instead. And that's super interesting to me personally.
Yeah, the why is always interesting, because if you know the why in software architecture, for me the why, if I know the why, for me the software becomes maintainable, because you know why the decision was made, so you know now how to change it. And in our case, or for your case, you can now explain better now how this try with resources is working as it is working, because in the background. Without the background, it's really hard to really understand what's going on.
Yeah, and that's why I think so exactly say this why information, this context information, they're really important. And that's one of the things where that's a totally different topic though, but I'm really a fan of commenting code in a certain way. And what I try to say is that these why things, like these context information, they need to be somewhere. And you can put them into your commit messages, you can put them into issue discussions, you can put them into a wiki, and that's all fine, but that's also very far away from the code. So if you, like, for example, work on something for like 60 minutes and then realize this way doesn't work, I have to try something else, I recommend put that in the code. Put a comment in the code saying like, I'm using this API instead of the other API because that other API has this and that shortcoming, and that is the reason why it doesn't work here. These kind of information are super important. Like that, for example, could be something that would go into a POM maybe, or the build file saying, I use this dependency instead of that dependency for this and that reason. I use this version. I have to pin it to this old version because the newer version has a dependency conflict with that other dependency that we have, that kind of stuff. Or I picked this design pattern and not that design pattern because that other design pattern, which I tried first, doesn't work for that requirement that we have. That kind of information, if it's not in the code, it's really hard to recreate that piece of information without basically retracing the same steps. And that happened a couple of times to me. I was updating a code base to Java 9. I wanted to update dependencies. I fought dependency conflicts for like half a day until I figured out, okay, these are unresolvable. It just doesn't work. We have to wait for these two dependencies to release new versions. And at some point I realized, you know what? The version in the POM was already outdated by the time it was put into a POM, right? I can see it in the Git history. I'm pretty sure that the person who put that version, they knew that. They probably tried the same things I did. They probably also spent half a day and then realized, shit, the new version doesn't work. I'm going to put in a slightly older version. If only they would have spent an extra minute explaining, I could have saved like half a day.
Yeah.
And so really, I'm a friend of a proponent. Really, like I'm telling people that if you make one of these decisions, I tried X and it didn't work. Put that somewhere. And I think the code is often the best place because it's the most immediate place. It's the easiest to find. You can put that into a wiki article about your design and architecture somewhere. It turns out like that's probably not going to be something that people have at least read so recently that they know it by heart.
Absolutely.
Probably they don't read it at all.
I send you in a chat a link to a blog post, very short one. This is already 9 years old, and this is how to comment with JavaDoc. And I got this hint from someone. This was the Kai Windmüller. And what it states is about JavaDoc, the what in the name, put the how in the code, and the why in the comment. So exactly what you said. And what's about JavaDoc, what I also highly appreciate is the quality of JavaDoc in JDK itself. So now now we can argue about that, but if you look at the string JavaDoc comments and the older comments, they happened at JDK 1.0 time, so 1995. And the quality was still high. I mean, not high like there's lots of comments, but they always explain why. And I was, and a lot, like the quality boards or code reviews or whatever in various companies. And they asked me about, what they wanted to have is they wanted to, to comment all public JavaDocs, all public methods with JavaDoc. And I said, okay, but this is just stupid. Let's assume we have getters and setters. What you would like to write there, right? This is like getters a setter, and this is a default constructor. So this is like, for me, it is offending the developer because everyone knows what getter and setter is. And what larger companies are searching for is like, a rule how to automatically increase the software quality without any effort. Like, so just generate getters and setters, and I think, okay, now we have a great documentation, which is counterproductive. So I would say writing a good JavaDoc, it takes some time, and as you said, you have to think why I did it. And the cool story is now, if you don't know why you do this, just delete it. Because there are lots, of software which does nothing interesting, like, copying back and forth objects or just doing stuff which is actually, there's no added value, no business value. And if you cannot justify why you're doing this, it's probably not worth of doing this at all. And you can just, write simple Java code which expresses, perfectly the business requirements and not spend your time, hunting some old, outdated patterns.
Yeah, so about JavaDoc. So what I really think is, so these why comments that I just mentioned, it depends on who you're addressing, right? So when I'm writing a project, let's say it's an app, and I'm addressing my teammates, right? Mm-hmm. Who also read the code. I would probably not put a whole lot of that why stuff into a JavaDoc, because to me, JavaDoc is something very specific. To me, a JavaDoc, first and foremost, establishes a contract. Mm-hmm. It promises me how this thing will behave. Mm-hmm. And that's what we used to, right? That's where JavaDocs shine. Like if you look at, the collections framework, mm-hmm. or the lists, mm-hmm. and all of that, right? Mm-hmm. All of these APIs, we explore them. That's how we understand them. We read the JavaDoc and we say, okay, this is what the code promises us. And we usually don't think about looking at the implementation. Mm-hmm. And so when people say, well, you don't need comments because the code is self-explanatory, I'm like, okay, if you believe that, then never read JavaDoc ever again. Just look at the code. Look at, I don't know. For example, there was a great example. There's something Google's Guava does, like a type token that helps with reflection. And I challenge people. Yeah, go look at that code and tell me what the contract is. Yeah. Or, you want to establish the contract by tests? Great. There are like a couple of hundreds and hundreds of tests for the collections framework.
Exactly.
Look at that, and then tell me what the contract is. Mm-hmm. So I think that's just a plainly, sorry for the word, stupid idea. Yeah. If something establishes a contract, looking at all the implementations and all the tests is the worst way to learn about it. So instead, well, it's not the worst way. You can probably just do guessing, which is even worse. But it's not a good way, at least, to learn about it. So a contract, something there. So this is the central abstraction of this piece of code. This is what it does. I think that often deserves a comment. But then also, of course, writing JavaDoc takes time, and it means that this stuff can get out of sync. And is it how useful is it to the readers? So what I basically recommend is every class should have a JavaDoc at the top that has like 1, 2, 3 sentences explaining what the basic abstraction and basic task of that class is.
Yeah.
Now, if that class gets to be reused, if you know what I'm writing here is a low-level utility that's probably going to be reused a whole lot, then spend the time describing what the methods do as well. If you're writing some piece of code that probably is only going to be called from that other class that you're writing right now, like maybe you have a package visible class that you only use in one place, sure, there's no reason to write like contract comments for all the things, right? That's fine. Leave it like if it's just one place that's used, it's okay to have the code explain itself. So that's one rule, I think, right? Just like the more it's reused.
I would extend on that. I would expect if the class is important, I would also expect an example in JavaDoc. So you can absolutely give a use example or point to a unit test, which already has the example. Because from the examples, this is what makes the, Sun or Oracle newer or Sunny, what do I mean, the core JavaDoc comments actually great.
Yeah. So JavaDoc, by the way, gets, and I think JDK 18 gets a really boost in that area. It now has a snippet tag. And you can use a snippet tag to have like a multi-line code block there, but that's not really new. But what you can use it for is you can reference another source file and then reference also a section of that source file that you want to embed. And that is amazing because what can quickly happen if you put source code into comments is you change the code it references, but of course you never know, right? Because the comment the piece of code in the comment usually isn't compiled. But what you can now do, you can have, let's say, in a usual structure is source main Java, right? And source test Java. Now maybe you also have like source demo Java, for example. And that's where you put on all your files that are just demonstrations of how to use your API. They can be compiled. If you do it well, you can even run tests in them. So you can not only make sure that they're compiled, you can also make sure that they behave as you want them to. And then you pull snippets out of that into your JavaDoc or actually into other documentation as well, right? So ASCII-Doc, for example, has a feature like that as well. And I think that's the best way to write, to reference examples. And you're perfectly fine. You're perfectly right. So JavaDoc, for example, that says at the top of the class, this is what the class is about. Here are a few example ways to use it. That's great. That's great information. If I want to use that class, that makes it so much easier for me to just get started and not have to spend the time rebuilding what the author of the class already knew, right? Because that's what you're doing. Like every user comes around and has to rebuild from tests, from code, the contract in their head, then use it, and then forget it and do the same thing a couple months later.
In backend or business projects, what I also do is I say, okay, the Java package should have specific meaning. And the topmost package, because you mentioned utility, the topmost packages are always named about business by business responsibility. So in a project like Netflix, you would have client streams, videos, movies, or whatever. And but what I don't allow is generic names like util or common or foundation, because you will end up putting everything there. It's like Java util was also a bad idea, to allow Java util at the top level, because there's everything there, right? So and then what you have, we have a package with a business meaning. For me, is the Java package has similar granularity as a huge Java object. Like on Amazon, it would be shopping cart. You cannot just implement a shopping cart on one class. You already know it is more than one class. So you can just add, create a Java package with the name shopping cart. And then what I like to do is to implement package-info.java, like package doc. So what I would expect at least that you have one package-info Java exactly, and with a single line of JavaDoc which describes what is the responsibility of this entire module, and this at least thing which I'm expecting, because then you already know, okay, this is the implementation of shopping cart, what it does, and so forth. And then I'm with you, and all the more important classes, I would implement the why, what it does, and maybe a link to some external part, and this basically it. So you are not required to implement. If you say nothing, means it's trivial. if you write JavaDoc, you're already explaining why it's not trivial. So what happens behind the scenes? What is the ideas? This is my approach, and it works actually well. Except there are no metrics for the existence of package-info.java. So large projects don't write it that much because they don't have any credit, no stats. So they write like crazy, JavaDocs for getters and setters, but skip this package info because it does not appear in the stats.
So I think one thing is very important. You mentioned JavaDoc or getters and setters. I wanted to comment on that. That's of course the poster child for pointless comments, right? Set name has the JavaDoc, which just sets the name, and then has the variable name, which has to comment the name. I mean, that nobody needs that. Nobody, at least nobody I know who
no,
argues
this is defect.
That comments are important.
What I do is defect.
Argues.
If I see this, I say, okay, this is defect, delete it. Because if you generate JavaDoc, and someone will try to read it, you can redirect the entire thing to dev null. No one will read this is a getter and setter. Or even worse, this is a class. This is a class with the name string. This is the default construct of the class string. I mean, and this is a toString method which generates toString. So okay, I mean, what I say, if you go to, let's say, to a garage or to a shop, to a sports shop, and they will see, this is a shoe, this is a T-shirt, this is a white jacket. It's just like completely stupid, When you see on the sticker there, maybe this is a jacket with specific attributes, but not this is a green jacket. You won't see that.
Yeah, so I think that's actually important. Like there are obviously very bad comments. And when I say I argue for comments, I don't argue for those.
Yeah, so this is what I understood, which is very good. Yeah.
Yeah. And the other thing that you also mentioned is, when there are metrics, there are no metrics for package info, then people don't write comments for that.
Yeah.
Because the thing is this, as soon as you introduce a metric, like people don't have to be, like people are not explicitly thinking, well, sometimes maybe they are, but usually they're not like, I will not write a package info comment because it doesn't help me with the metric, but I will write one on the getter. That's not really a conscious thought process in most people. It's just the way it happens by default. Like if you introduce a metric, people will start behaving according to that metric just because that's kind of what a metric is about. Like you're interested in those numbers, you're interested in in pushing those metrics where you want them to have. And so if you have those and you focus on them, and if you have a large business, if you have a large company or a large organization, it's typical for higher ups to just focus on these numbers because that's, they cannot come to your code and read all of your comments and decide whether your comments are good. So there's always this danger that when you establish certain metrics, they become important and then they will drive decisions, whether those decisions make sense in the context of the original reason to introduce the metric or not. If you feel our code has poor comments, we need to be better with that, or has bad testing, or whatever. And you then think, okay, we want to get better at that. That's good. We want to have a metric for that. That's also not bad, but then be really careful to make sure that this metric does not get gamed. And once again, I don't think this is malfeasance. People are not doing that because they're like evil people. It's just what happens. If there's a metric, it's just a natural behavior. If something gets measured to improve that measurement.
I mean,
even in situations where it doesn't work that well.
It's not a problem of developers, I would say, because the developers.
It's a general problem, definitely.
Yeah, when there is the problem of management, because they require specific contracts. If you're a independent software vendor, you have to deliver the software, and they say, okay, all public methods has to be commented. So so what I can do is I won't write comments for getters and setters. I will generate them because I mean this is what I should write, right? And even worse. Now, what I see is even worse than JavaDoc are actually recommendations for JUnit tests. Like 80% of the entire API has to be unit tested, code coverage. What I already see is I saw already unit tests for enums, unit tests for exceptions, unit tests, for getters and setters, where there was reflection tools built just to invoke all the getters and setters to increase the code coverage. And this is really bad. And I don't know whether you know the JAX-RS API, like the REST API. For instance, if you have the first layer JAX-RS, nothing happens there. It just, gets, from, it just reacts to get, post, and so forth. And you get the HTTP header maybe sometimes, and you return the response. And what I already see, one-to-one, line-by-line unit tests, we just replicate whatever happens in the JAX-RS layer. What means is...
You're testing...
Yeah.
It happens fast. You end up testing the framework. You end up testing Java. Like you use the date API. You write a little bit of code over the date API, and then your tests feed that code a bit of stuff, and then test it. What you like, not always, right? But what you may end up doing is you're basically just testing whether the Java date implementation is correct or datetime implementation, which it probably
or mocks.
is.
You know what they do is they mock it out and they see whether the mock returned, what was previously feeded, and the overhead is huge. And my concern is, every change now in Java code requires a huge refactorings of the unit tests, because every small, change of the behavior, which is irrelevant, has to be, the unit test has to be adapted, because what they are changing, whether what they are testing or verifying is whether, the mocks behave this way as they behaved before. It means it becomes too expensive. And now management sees that and it says, okay, why the maintenance of Java code is that expensive? Why we should not look at Python or JavaScript, because they are not doing that. So the only difference between us Java developers is we have the tools, and sometimes we are forced, to deliver such pointless code. And in Python and the other programming languages, they are not that far. They don't have such toolings, and no one cares about such numbers. So this is unfair comparison between Java productivity and the scripting language productivities, because the entire context is different. So what I try to do is just to be productive with Java, and whatever is pointless, just skip it. So this is a very important part. Otherwise, Java code becomes just too expensive to maintain.
Yeah, I think like the ways to write tests that you describe. Now that the way we talk about it, it's obvious that they're pointless. But sometimes when you're in the midst of it, it's not that obvious that's what you're doing, right? If you test a getter, you probably know, like if you create a method, create an instance, and then call a setter, and then call a getter, and then verify that it's the right thing, you probably know that what you're doing is not the greatest thing to do. But specifically that you sometimes accidentally just test the underlying code, whether like the framework that you're using or the API that you're using, whether that behaves correctly or not, that you're accidentally just testing that or mostly testing that. That's not always immediately obvious, but you're right. Like it happens, like when you focus on test coverage too much, or if you say like it must have X%, then that's what happens. But at the same time, like in the project that I mentioned earlier, it's JNet Pioneer, by the way, where we only use SOJ assertions, right? We also have test coverage that's measured, but it's not like you have to have X% for it to be able to merge, because then you end up with testing as you described, like, hey, does the constructor actually work? Like, surprise, it does.
Yeah.
But still, you want to look at, I think what this is important for is not as a metric to achieve a certain level, but as a measurement of where might still be work to do, right? So, for example, let's say you evaluate test coverage across your entire project, and you say it's like on average, let's say 80%, but you have one of those that has just like 40. You're like, well, what's there? Like maybe there's a good reason. Maybe you look at that and it's like, it's all just glue code. It all just deals with some Spring stuff. Okay, we don't need to test that. That might be perfectly fine, right? But this is like a pointer to where maybe you want to check out whether things are okay. Maybe you realize like, oh wait, no, this is just a code that was written like very recently by somebody who later, applied for a job elsewhere and they didn't get around to writing all the tests they maybe would have wanted to or whatever. Maybe the person was, never writes tests. The reason, what I'm saying is, maybe realize, oh wait, no, there should be more tests, and then maybe now is the time to write them before we change the underlying code, and then we get bugs because we didn't notice that we accidentally changed behavior. And you're right, not every small behavior change needs to break a test, but every small behavior change that other code relies on, that should break a test. And it's often like when you TDD, it's probably theoretically every behavior is in there because reason. But yeah, in real life, it happens that you code a behavior that you don't actually need specifically for the clients that use that class. And then if there's a unit test that tests that, so that's the difference between a contract and implementation, right?
But I think the difference is
the test should verify the contract and not the implementation details.
I would say the huge difference, whether the metrics are established by the team or by external entity or management, if you cannot influence the metrics and you are measured by external metrics, this is the problem. And you probably know.
Yeah, specifically if it's used in a hierarchical situation where other people are going to judge you or
exactly.
your competence or your how much money you get based on those metrics. That's a horrible situation, because then people are surely going to game it, like probably many of them on purpose, and the other ones, as I mentioned earlier, just because that's apparently what is expected, and that's just going to happen then. So yeah, if management comes in and says you need 90% test coverage, better prepare for tested getters and setters.
Yeah, what we did in such projects, no kidding, there was no way, to convince management to do something different. So we introduced annotation pointless, and we put on the code, and I see whatever you see this, we just had to do this. So there was actually, you can delete it afterwards. So this was actually an interesting approach. No kidding.
I mean, that's fair though. Like, it's like if as a developer, I know that there's bullshit code in this code base because I have to put it there. At least if it's pointed out, that's nice, actually.
Yeah, this is actually a common pattern in some project. If you I have no chance, to change the world, so I do this, and so okay, pointless, just forget about that, and I don't know whether SonarQube probably, or Sonar. And back then they had a great metrics. This is harder to get right now, and it was called Project Cloud, I think, the metric. And what we did, we combined the cyclomatic complexity with test coverage. And you got a overview. It looked like maybe tags. And every class was listed in a cloud. And the larger the font size, the more complex the code. And the color was test coverage. So green was 100% and red was nothing. And we had a simple rule in a project. Big red font is prohibited. So you will have to make it simpler or more tests. And this was the best, choice ever, because the combination is great. Because if a complex code is probably not that testable, and if you reduce the complexity, it becomes more testable and you solve the problem. So this was actually a great approach, but exactly this metric becomes harder and harder to get in the recent Sonar versions.
Oh, okay. Yeah, that's actually a good idea. I think like combining that and saying like, look, we don't have to have 100% test coverage, but if you like, the more complex something is, the more tested it should probably be.
Yeah. And there's an old framework I tried to, or library. I don't know whether you know. It's called crap4j. It is still there, crap4j.org, and it tried to do something similar. It looks outdated. It's probably implemented with AWT. I put it in the show notes and in the chat, so you can look at that. But it was a standalone framework which did it. It's called crap4j, and it was 2007. It's an old stuff. Hey, Nicola.
Oh yeah! Oh my God! This webpage. This looks amazing. It's like that's 2000s Java. Nice.
Yeah, it's really nice. And look, we didn't cover the newest Java stuff, but it was interesting enough. So I will have to reinvite you back again, and then we should really have to talk about Java 17 and Java 18. And but it was a really great conversation. I didn't know actually you spend that much time with Java, and your thoughts about unit testing very interesting. And cool. So where people can find you? Do you have a blog? Twitter? You have it. So
yes.
Just mention.
Yeah, I'm NipaFX everywhere. So NipaFX is on Twitter, on YouTube. NipaFX.dev is my website. Mm-hmm. So if interested in more random ramblings. So yes, I spent most of my time digging through the newest Java stuff. But as you've maybe been surprised to hear, just as Adam has, I do other stuff as well.
Yeah.
And I have opinions on everything. So not all of them are good. But I do. So that's where people can find me. And you can ping me anytime. I have a Discord as well. If you go to nipafx.dev, there's a Discord at the top where you can join us on some random Java conversations. And yeah. So thank you, Adam, for having me. That was really great fun. And yes, you're right. Like every time we plan, like let's talk about the new features, and then we didn't. Hey, we talked about one Java 9 feature and about the snippet tag in Java 18. So
and you tried to sell us, this old Java 1.9 logging as new. So
right. Like like. That's how you can tell. That's how you can tell that people are getting old when they think something is new that was actually done like 4 years ago, because that was a new thing for them, though they still think it's new.
Or crap4j from 2007. This is even better. The newest framework.
Yeah.
Okay, cool. Thank you. See you next time.
See you. Bye.